Okay. Okay, welcome everyone to HAO Colloquium today. Our speaker is Hannah Rosell. She will be speaking on the observatory at Climax, Art, Science, and the history of the High Altitude Observatory. It is my great pleasure to introduce Hannah. Hannah Rosell, a historian of science and art and a moving image artist, is a full professor at the University of Colorado Boulder. She created the exhibition Climax, History, Science, Art, and at NCAR's Mesa Lab in spring 2025. The author of multiple monographs, edited volumes, and award-winning documentaries, he is currently completing a film about the history of HAO with the support of University of Colorado Research and Innovation Seed Grant. So,
Great. Well, thank you so much for that nice introduction, and it is really great to be here. Thanks for coming. Yeah, it's a real pleasure, and I'm really grateful to several of you in the room who have talked to me about HAO and who've been really supportive and who are, I feel, as kind of collaborators in the project. Joan, in particular, has been a great kind of like friend and guide, helping to kind of open up this really rich and interesting history. Okay, so hopefully there'll be some time at the end of the talk too to kind of answer questions, but also to kind of just ask for people's contributions and thoughts would be very helpful and interesting. Okay, so the observatory at Climax, Art, Science, and the History of the High Altitude Observatory. In 1940 and 1947, the founding director of the National Center for Atmospheric Research, then a newlywed graduate student from Boston, lived with his family in a small observatory located atop a vast mining operation. Walter Roberts was superintendent of what was then called Fremont Pass Station, located adjacent to the highest settlement in the continental United States. So here it is now. The Climax Molybdenum Company, which extracted molybdenite ore to create steel alloys for engines and weapon systems, collaborated in the late 1930s and, for decades after, initially with Harvard University to establish what was North America's first coronagraph used to study the corona, the gaseous halo around the sun, of which you all know so much infinitely more than almost anybody. So here's Climax back then. As an artist and historian, I've been fascinated by the Coronagraph Observatory, Fremont Pass Station, erected atop the Climax molybdenum mine since I first arrived in Colorado, somewhat like Walter Roberts and his wife Janet Roberts and their scientific equipment alike, all transplants from Massachusetts, never quite having seen the mountains before. So for me, both the historical legacy and the kind of present day reality of the former site of the Climax High Altitude Observatory, as kind of an artist and a historian, exemplifies a kind of liminality. So I've been very compelled, kind of like aesthetically, poetically, between the idea of the darkness and the light, the reaches of the heavens and the depths of the earth, the vital energies that kind of prompt scientific discovery, into astrophysics and the regeneration of nature on the one hand, and on the other hand, the kind of potential hazards that accompany the human drive for both raw materials and knowledge of the cosmos. So I don't know if how many of you have seen Climax molybdenum mine. It's kind of right on 91 if you're driving between Frisco and Leadville. It's kind of gorgeous in its way, but there's a really huge environmental impact and kind of geographical impact that the mine has had on the landscape over the past decades. So part of this story as well, though, is understanding the history of the High Altitude Observatory itself. Over the past couple of years, I've been developing a series of kind of like hybrid art projects that engage with Climax, with the kind of history of the Climax mine and kind of my own relationship with also the kind of early records of the High Altitude Observatory. And here's one kind of manifestation. Here is just a kind of still from from an event that Joan and actually several people from the HAO came to. Yeah. Yeah, right there in the chair, special comfortable chair. So anyway, I've really been like exploring the history of this observatory in different kinds of ways. So today I'll just like to kind of lay out the historical context and show some edited clips from the film I have underway. So we'll get started in Climax, the molybdenum mine in 1940. Here you can see the kind of like entry gate. I love this photograph. There was a photographer named Marion Walcott, and she worked kind of with Dorothea Lange for the FSA, the Farm Security Administration, in the Office of War Information. And lucky for me, did a really beautiful series of photographs of the Climax mine from 1940, 1941. So built on the Continental Divide at 11,500 feet above sea level, on and with the support of the Climax Company, which was then the world's largest and deepest underground mining operation, the Climax High Altitude Observatory was transformative in multiple ways. Both the information abstracted from the solar imagery, so you can see on the right, and the metals extracted from the tunnels beneath during these years in the 1940s came to have profound strategic importance during World War II. Specifically, it was determined during World War II that the solar activities being observed and documented and kind of analyzed and transmitted to Washington could have great predictive power as to the reliability of long-distance radio communications, and thereby help schedule some of the major offensive military campaigns during World War II. So how did this like interesting confluence between astronomy on the one hand and kind of underground mining on the other hand come together? So I just want to explore that a little bit. In late 1939, Harvard astrophysicist Donald Menzel, under the auspices of the Harvard College Observatory, which itself was at the time under the directorship of Harlow Shapley, undertook a new project to detect the solar corona, the ring of energy around the sun, until then generally only clearly visible during full eclipses. For millennia, of course, people had looked up at the sky and wondered about the halo around the sun, beguiling in the haze, but generally overpowered by the intensity of the sun itself. Eclipses were portents to some, startling to others, and comforting to others as well. A kind of light is visible about the rim, which keeps the shadow from being profound and absolute. Darkness covered the earth, and all the brightest stars shone forth, and it was possible to see the disk of the sun dull and unlit, and a dim and feeble glow like a narrow band shining in a circle around the edge of the disk. So this is Leo, Deacon of Constantinople from 986. A decade after the famous Carrington event of 1859, the greatest solar storm in history, an atomic green line in the corona was detected, followed by an ever-increasing desire among scientists, as well as kind of amateurs everywhere, to understand the swoops of bright gaseous light emanating from the photosphere. And the question became, could detailed photographs of the solar atmosphere be made without chasing after fleeting occurrences of eclipses in the wild? A method had emerged by the 1930s, a technique to eliminate the glare of the solar disk with a series of filters, specialty lenses, and diaphragms called a coronagraph. The invention occurred in France by Bernard Liot, but astronomers at Harvard decided that the Western Hemisphere needed one of its own. A decision was made, and there is a strange story here, to set it up in Colorado in collaboration with the molybdenum mine at the base of Bartlett Mountain on the Continental Divide. So Fremont Pass marks not only the Continental Divide, but also the western edge of the 1803 Louisiana Purchase. During World War I, a New York City-based syndicate opened the Climax mine, called Climax because it was the highest point on the railroad line, to extract molybdenum, for which a use was finally identified. Climax, Colorado soon became the world's major supplier of molybdenum, used in steel alloys for armor plating for howitzers, gun barrels, innards, and other engines of the First World War on and through the 1920s and early 30s. So by 1936, when Menzel started thinking about coronagraphs, Climax had its own ore processing facilities and had a company town, recreation center, schools, and a store. By 1937, and this is a kind of a map from around that time, there was also a hotel and a hospital on site at Climax. It was a place to be. So through a lot of kind of interesting conversations, which I think are just like kind of fascinating in terms of thinking about how collaborations can happen between, industry and education and between kind of different fields of science and kind of domains of society. Climax agreed to provide Harvard with the site, access to its utilities, as well as collaboration on constructing the observatory, the darkroom, and the cabin where Walter R. Roberts and his wife and eventually their children would end up living. And Climax provided a long-term lease on a plot of land. So work on the design of the observatory, the coronagraph, and more was done mostly in Cambridge, Massachusetts, as well as at Oak Ridge Observatory, which is in the suburbs of Boston in a town called Harvard, Boston. And, there were all sorts of questions of instrumentation and lens making and work, between Rochester and France and the US that kind of went on. So you can see here on the right, there's like a diagram of the instrument as it was being developed. And then on the left is like things getting kind of set up again at the Oak Ridge Observatory in the kind of in the woods, an observatory that was, I guess, good for setting things up, but was not good for observing anything. And I just have to show, I tracked it down. There it is. Yeah, that's the spot. And the Oak Ridge Observatory is now kind of like in ruins, or there's old buildings, there are old structures, but nothing's in use. But I took photographs of a lot of these in the woods, and then Tom Bogdan, who I'm sure people know, helped me confirm that this was the one, by looking at this and looking at that. So it's really neat. So Menzel instructed his 25-year-old graduate student, Walter Roberts, and his wife, whom he just married, Janet, to drive cross-country to work with engineers to finalize construction, and then to kind of oversee the Western Hemisphere's first coronagraph observatory. And this is like not what Walter Roberts had been expecting, as his like dissertation project. He was kind of a New Englander, as it were, and I think that was kind of his plan. And indeed, it was supposed to be a relatively short stint, but little did Walter and Janet know at the time, but the two would end up spending most of the coming decade at the Climax Observatory, and in fact would end up becoming pretty ensconced, as we know, in the kind of Boulder and Colorado world. So what I want to do is, one of the things I've been working on in this project is taking the voice of Walter Roberts' wife, Janet. She wrote a beautiful memoir of her time living at Climax in the observatory. So I've been kind of thinking about using her words and her perspective as a way to kind of tell the history of this place. So I'll just read from that. The house, and this is, I'm being Janet Smock Roberts right now. So the house in the observatory stood on a small hill at the base of Ceresco Ridge, a quarter of a mile above the houses of the mining camp, and not far from the great gouges in Mount Bartlett that had been created by the molybdenum mining, the glory halls, so-called, because the holes in the mountain faintly resemble the trumpet-shaped flowers of the morning glory vine. So you can see the glory hole kind of on the map over there. There it is today. So once assembled, the Climax High Altitude Observatory provided a lens, or more literally, a lens and a blackout window pointed high into the sky, housing a massive instrument to simulate a solar eclipse, as well as attached to it a darkroom for developing solar films and photographs. With Walter at the helm and with Janet's assistance, and initially it was just the two of them, although eventually more people kind of came on to join, the coronagraph was intended to produce day after day's photographic and filmic documentation. This in turn would enable analysis of the various intriguing movements of the solar corona, and ideally the face of the sun itself, flares, as well as what was commonly known then as prominences, what has been identified more recently since then as coronal mass ejections, and other forms of explosive energy fields emanating from and surrounding the sun. So perhaps unsurprisingly, when you're trying to set this operation up on top of like a super dusty mine when the weather is like freezing and you're all alone, there were incredible difficulties getting things up and running. There was building the observatory, there was the dark room, the filters, the instrumentation, endless dust, and unpredictable weather. And these were documented in copious letters, telegrams, daily report sheets, and strips of fog film. And so I've had the pleasure and the horror, I guess, of like looking through a lot of these, a lot of the correspondence that Walter Roberts was kind of sending back and forth with Menzel, like telegrams about problems and things. And I'll just show. Okay, this is kind of funny. So Walter Roberts would, for a while, he was like sending films, right? Like literally sending them, like he would develop them and they would have to go to Leadville and the post office, and then it would have to get shipped to Harvard. And then Menzel would, this is like dictation that he was doing for a while, where literally Menzel would like watch and sort of describe his reaction to like everything he saw. So it was like not particularly beautiful, very beautiful, so we just sort of going blow by blow and having his secretary record all of the mistakes. Not particularly interesting. It's just sort of funny the way that documentation of things not working out can kind of accumulate. So the initial idea, as I mentioned, had been that the stint at Climax would be short term. Walter Roberts' goal for the dissertation project that had been given to him by his advisor was to kind of get things up and running and do kind of like a proof of concept. And after that, he would return east, defend his dissertation, and start a job in the research department at Eastman Kodak in Rochester. He had already done a series of internships with Mies, who was in charge of research and development, and was into photography and emulsions and kind of physical chemistry. But so here's just like when he's kind of in the early days trying to get things settled. And but the full proof of concept wasn't ready yet. Climax became a secure armed camp due to the strategic value of molybdenum as an alloy for bombers, takers, and munitions. And that was the case by 1940. And then in December 1941, Pearl Harbor happened. The mine and the observatory both went into lockdown, as both were recognized by that point as having either actual or potential extreme strategic national value. This is American bombers trying to bomb molybdenum mines in Norway. So kind of like the other big molybdenum mine at the time was in Norway, which was then under control, Nazi control. So molybdenum was like a really big business. And it had a lot of it was military kind of importance at the time. So indeed, between 1942 and 1945, Roberts conducted what was top secret research in World War II, helping the Allies forecast ionospheric phenomena that would interfere with shortwave, long-range radio interference. And here's just some of the kind of like initial work. So in a sense, as the astronomer at Climax looked up higher and higher into the sky, engaging ever more deeply in the relationship between Earth and Sun, sharing his findings with military officials in Washington, D.C., and in turn across the world, the mining company that was kind of hosting him and with whom he became quite friendly, created more and more tunnels, expanding tailings and waste ponds, digging ever deeper into the ground. So here is another recollection from Welter's wife, Janet. To mine, long tunnels were bored in from levels, which were the base for mining operations. These long tunnels enabled ore trains, several open bed cars hooked together, to penetrate into the heart of the mountain. There the miners planted dynamite, high in the timbers supporting the roof of the cavern, lighted the dynamite and made a dangerously quick getaway. The subsequent explosion brought down huge chunks of ore-laden rock, then hauled out to the mill and the smelter. Eventually, the blasting broke through to the surface of the mountain. So during this time, twice each day, weather permitting, astronomers used the only suitable coronagraph in Allied hands to photograph the sun, then measured and interpreted the flares. But the military context and the dramatic rate of geological change around him had, at least in kind of the way that I understand the project and I understand aspects of Walter Roberts' life, had a great impact on him. The dust that rose from the mining camp impacted not only the possibility of good seeing, in a kind of in the sense that, you know, astronomers talk about good seeing, but also his own kind of clarity of purpose about what he was doing and why. And that's something I'll come back to again. So what I'd like to do now, I'm just going to screen like an 8-minute section from a documentary film that I'm working on. And what you'll see is actually like a reworking by, you know, me and an editor of some of the various archival imagery that was produced at Climax. I mean, it wasn't archival imagery at the time, but part of it is a reworking of a film that Walter Roberts and Menzel and others produced around 1946 as part of a bid to get funding in once the Army and the Navy, once funding kind of after the war, it was harder to get funding. And so more private donors needed to be brought in. So anyway, part of this is from a kind of a promotional film in that sense. And it's silent. All right, it's a little slow. See. All right, I feel like it's not doing great. Well, we're going to watch a little bit here and then I'm going to keep going. We'll figure out. You can get kind of really see what's going on. Get into the
So what kind of camera you would have shot this with?
Yeah, it was with a 30-foot. So this was a 35mm camera that he was that was being used to shoot the flares and everything. But the film that this is taken from is a 16mm film. So the research films were on 35mm. But then when a kind of promotional film was made, it was made out of 16mm because it's easy to circulate a 16mm film to kind of, you know, carry it around. But yeah, the original work was on 35mm. Okay. All right. I'm happy like afterwards to maybe show it in another format, not kind of streaming, and then we can play it all. Okay. So here's Climax now. So Climax was then and remains in its own way kind of sublime. Its fusion of the natural and the technological. And I kind of think a lot about, you know, how it would have seemed and how Walter Roberts, as a scientist, but also as a kind of, you know, very social, engaged person from a very different landscape, would have been affected by his time there, in addition to his wife. So it exemplifies a kind of liminality between darkness and light, the heavens and the depths of the earth. So this is an aerial photograph from 1944, and it sort of shows like what the landscape was like. There's like a little housing development. That was the community where the miners were all living. The observatory at the time, I'm not going to get up and look, but the observatory at the time was kind of like in the mountains, kind of overlooking where the little housing kind of development is. as Janet reflected, here I am as Janet again. When we came there in 1940, there were 2 huge open wounds on the face of Mount Bartlett. While we lived there, we watched, standing on our small kitchen stoop, the bridge between them give way with a thunderous roar. The sound, because of the distance, arrived eerily late, seconds after the clouds of rock dust had risen to the sky. Okay, so eventually the war ended. And my sense is to think about Walter Roberts' experience of the mine and how it might have shifted his outlook in his future, instigating a passion that ended up becoming very, very strong and important for activism and for bridging what is often a meandering path between science and society, as well as between different disciplines of science and, kind of how science can kind of expand across, different kind of arenas and different domains of expertise and kind of areas of inquiry, I guess. So rather than a spirit of pessimism, Roberts' approach was then, and throughout his life, as far as I can tell, was rooted in a kind of a spirit of optimism and an idealism about technology and human potential, albeit tempered by the exigencies of nature, and particularly of kind of the human drive to want to kind of wage war. Okay. But just heading back to this kind of moment after World War II, eventually he finished his dissertation. He actually finished getting the kind of proof of concept up and running during the war. So he had kind of this like restricted classified dissertation, but eventually he finished, and here it is. Here's this like the original copy signed and sealed. And meanwhile, even as the dissertation is declassified, the research at Climax Observatory continues. This is just like a very famous, like, big prominence that was produced on June 4th, 1946. So at the same time, over the next coming years, Roberts was sort of appointed as the director of the High Altitude Observatory in the late 1940s, the headquarters of which kind of moved down to Boulder, even as observations continued up at the Fremont Path Station. And so here we can kind of see its early developments. And at the same time, he went on with others, kind of helping to find the means to relocate and expand the original site. To expand that original Climax Observatory, which both was super dusty, was small, and also ended up kind of being in the location that would turn into that big pit. So eventually, and here I have some postcards that show you can pass these around if you want, that show the kind of new the new site. This is like a postcard, which I think maybe several of you have seen, but I hear it's like got a lot of character because people always comment like that the car is red, but the reflection is yellow. So it's like a big Climax Observatory joke about this postcard. And I think one of the postcards that I have is that postcard. Thank you, eBay. And endless searching for that postcard. Okay, so at the same time as the military value of the work was becoming clear, Walter was becoming increasingly political. So, this is just from late 1945, the kind of a lot of publicity, or there was quite a bit of publicity around the kind of role that the Climax Observatory had played in World War II, at the same time as Donald Menzel kind of was mobilizing some of the research done at Climax to sort of develop theories and understandings of radio propagation to be used kind of more generally. But at the same time, and I'm grateful to Tom Bogdan, who maybe is online, but anyway, Tom Bogdan very kindly shared with me, he'd gone through and found all of these, the articles that Walter Roberts wrote for the Denver Post every week for a couple years on Sundays. He became kind of, he started having very kind of strong opinions about how atomic energy should be regulated, about how science should be regulated, about solar energy, about the relationship between the US and Russia or the Soviet Union, and kind of openness and internationalism in science. So that was something else he kind of got into. And so this kind of awareness of the power of the sun in relation to kind of atomic energy really then got him on track, or became part and parcel of this drive to expand what science was for, and also to start creating bridges between solar astronomy and other kind of branches of weather, and part of the whole kind of development of space weather. Anyway, so NCAR, obviously, he eventually kind of built up with a lot of these ideas in mind. And then I would just say I had the great privilege to be able to present a bunch of this work at NCAR as part of like a solar event that I did last spring, and also was able to produce like a small art exhibition about this history, or about kind of situating the origins of NCAR, but high altitude HAO more specifically at Climax, thinking about how like art and science and history can kind of come together to sort of reveal things in new ways. And for those of you who might be interested, I think I did bring something about that here. You can, people who might want this, you're welcome to pass that around. You can just. And then also, this is just another piece of the kind of immersive video work that I did, also about trying to understand the site of the Climax Observatory in different kinds of ways, kind of get at this origin point, both for HAO, but also for Walter Roberts's kind of ideas about science and society. And I will just here, so I actually, for any of you who are interested in a field trip, a weekend trip to Leadville, I'm going to be presenting on the observatory at Climax, near Climax, in Leadville, in collaboration with Colorado Mountain College next Saturday. So I'll be doing kind of like immersive video projections. And this is just on the left, that's just like the poster from the event I did at NCAR in the spring. One of the things that's been very like fulfilling to me is just to sort of try to tell this really rich, interesting story, and share it with like both sides of this industrial academic partnership. You know what I mean? That sort of both the Climax molybdenum mine and the sort of Leadville community, which didn't have much knowledge about this interesting history, but then also with colleagues and scientists on this end of things. Okay, so there's also like a lot more of the history of this observatory and its legacy to be had or shared, but I don't want to take up too much time because I want to have time for some conversation. So I want to go back to Climax and also conclude with some of Janet Roberts's memoir. So the original site of the Climax Observatory sat high atop Ceresco Ridge, eventually succumbed to a combination of subsidence and the vast big shot explosions of the 1960s. So that was when this like vast underground mining operation became like an open pit operation. These transformed the mine from an underground operation to an open pit landscape. And actually, at the time, there was like reporting about the intensity of the explosion, that it was like a nuclear bomb, like that, that it shook the ground. It shook the ground to Denver. So as Janet Roberts described her return to Climax in the 1990s, pretty soon after her husband's death. Now, more than 40 years later, Mount Bartlett itself has vanished. So has Ceresco Ridge and the hill where our house stood. Bit by bit, the entire terrain was swallowed up by the glory holes, and now the glory holes are gone. Over the years, the relentless progress of glory hole mining on Bartlett Mountain eventually engulfed our gravel driveway and the horseshoe pits we had dug nearby, and the tall pine trees out back, between which Walter had strung my winter and summer clothesline. There it is. And the small wildflower garden he had so carefully cultivated by the front door. So let me return to the image with which I began. As I wrote in the artist statement for the show I did at NCAR, and people can take it along if they want, quote, "A place can be understood as an earthly reality defined by longitude and latitude, with physical features to be detailed by geologists, geographers, and documentary photographers. At the same time, place is affective, defined by a series of experiences in time and their impact on those who linger." So thank you so much. Happy to chat.
Thank you. So, yeah, questions.
So he sold the idea that you can observe the sun and predict radio transmission and the effect on the ionosphere, basically. And I'm curious to know, did they have ionosondes there? Or did they team with somewhere like Haystack Observatory? And what was the connection with up on Mount Evans, now called Mount
Blue sky.
Guy.
Blue Sky?
Yeah.
Thank you. I forgot the name. There was a group of people based out of later became MIT. It was actually my thesis advisor, so I know this is why I know about this. Where they were making observations up there, and I believe of the ionosphere. They kind of been doing the sun because you claimed that this was the only solar observatory that was happening during the war.
It was the only coronagraph.
The only coronagraph.
Yeah.
So they may have been observing the sun up on Mount Blue Sky. But I think they were also observing, they may have had an ionosonde up there. So I'm wondering with a radio telescope. I think they also had cosmic ray observations up there. But I mean, I'm wondering how they put this together. You had a plot that looked sort of like maybe a storm variation in the ionosphere or something. How did they relate the ionosphere to the solar activity? There had been at that time. I mean, I think it was the science was developed.
My understanding, and you, I would love to talk with you more about the Mount Blue Sky connection, and it's really fascinating. My understanding, and again, I'm probably the least solar physicist here. But my understanding is that there was a lot of knowledge being developed very actively at this time. But a lot of it was actually going underway in Germany. So that there was a lot of this is my sense, there was a lot of kind of intuition about relationships that hadn't quite been established. And there was a lot of research and work with coronagraphs going on in Germany and Switzerland, on a very different side of the war, right? And people were kind of catching wind, and there was actually some secret correspondence going on. People that were maybe slightly in the resistance were kind of sending information to Menzel in kind of surreptitious ways. So there was kind of a sense of an understanding that wasn't quite an understanding. I think it was based on that Menzel was able to get, funding from the military and was able to convince the government to sort of fund the Climax Observatory during the war. But I don't think that things were clearly known. I think that Menzel, prior to the war, had thought a lot about radio. But I don't think there was a specific understanding of how and of how one could use let's say these photographs, how you could kind of analyze these photographs and turn that into information to help.
There are many steps.
Yeah.
Between here and there. So it wasn't simple, even though they were developing. I mean, a lot of the radio science goes back to the post-First World War, where they first started using radio.
Yeah.
And then they began to notice that there were these things called whistles going up and down. And then they began to think about propagation and the bouncing of radio signals by the ionosphere. And there were textbooks being written, particularly in the UK, about this. And it was spreading over here. Maybe Sandra, you remember this history, but
there was a lot of
I'm no expert in this, no. Yeah.
Trying to remember is when Appleton got his
Yeah.
Nobel Prize.
Yeah,
That would be a landmark. wouldn't it?
But
I know that-
there must have been communication.
Yeah, so Walter,
Roberts was in contact with these scientists to find out what was.
Well, so I can, yeah, so the sort of, there's like a complicated logistics that was going on. So it wasn't like Walter was calling up, wasn't like being like, hey, the Battle of the Bulge, or I've got an idea. So he was sort of like a node in a bigger project that's the Center for Radio Propagation and I forget the name of the people in Washington, terrestrial magnetism. He was sort of providing information to a whole infrastructure in DC that was also actually drawing information from other sites around the country, possibly Mount Blue Sky. And then, it was from the kind of radio headquarters in DC that like information was being kind of conveyed and transmitted. From the like Walter Roberts end of things, I mean, he wasn't, at that time, he wasn't really like in charge in any way. He was sort of like a grunt doing the work of his advisor on the one hand, and then on the other hand, like the Navy that had been kind of that he was working under. And really what he was doing a lot of, and eventually he had somebody come on that was hired by the Navy to help him, would be to like take these photographs and these negatives to kind of make all of these detailed measurements using rulers from them to compile these long lists and then to kind of bring them to Leadville, where like a secret where there would be a secret telegram sent that kind of coded all of that information. So it would go to Washington. And yeah, then I'm sure there was like a lot of other steps.
I can't remember exactly when they were founded, but I would have thought the Naval Research Lab would surely be a fairly key node in this, right? I mean, yeah.
Is Tom Bogdan online?
No, he's not.
So there wouldn't, at the time, there wouldn't have been much value for most other solar observations to be on the top of Mount Blue Sky, right? It was really only a chronograph that would have made use of a high altitude site, and full disk white light or H-alpha images could have been done from anywhere. So I doubt they would have gone to the trouble of having.
Sunspots could have been measured anyway.
Right. I mean, so the advantage of Climax was you could potentially know that an active region was coming around, how active it was several days before you could see the on-disk structures, right? And so that's what its strategic advantage was in terms of.
As long as you got the like telegram, as long as you kind of worked fast enough, right?
Right.
Because there were so many of these like steps. It's amazing how many steps there were compared to like how you would do it now.
So where was the solar activity at this time? What was the solar cycle?
Well, 57. Well, 57 was max. So
57 was max.
So
So
46.
what's the max? Okay, so it was maximum.
And that's why like so in 1946, there's that big prominence. And that is during the solar kind of the peaking, I guess.
Granddaddy.
The granddaddy, yeah.
So
Extreme.
Yeah.
one useful little factoid is that NRL goes back to 1923 apparently. So that because I remember there was a big celebration for them a couple of years ago, which might actually be worth looking up because they produced some quite nice,
Okay.
what has the lab done type stuff
Yeah.
for that,
Great.
And connected to the rather the Appleton
Yeah.
lab and what they've been up to
Yeah.
at that time.
And what's the name of your person who was your advisor at the Mount Blue Sky?
So Hope Bridge, and he was involved in making these observations of top of Blue Sky, and he and then he went back to MIT where he started building plasma instruments, and I was involved with the Voyager.
Oh, wow. Okay.
15 months later. But I think they were observing, unfortunately, I've only been there once and now it's closed for 6 months to a year or something, a long closure. The road going up is closed down because they're fixing it some way. But I'd love to go back up there and be.
Yeah, I'd love to go up there then.
But they still have an observatory up.
They do, yeah.
Yeah.
sort of.
Sort of. Yeah.
Not really. DU is kind of, yeah.
Yeah, it's more an educational activity rather than.
An inaccessible educational activity, the best kind.
Yeah.
Other questions?
How many children did they have?
Four,
Four
and three of them were born at Climax.
That's what I was wondering. In
Yeah.
the hospital there.
Yeah, I think two of them were born at the hospital at Climax. One was in Denver.
Okay.
But Walter Roberts was really, I mean, I don't know, he's like a very personable person. So of course he became like really good friends with like the miners and the mining engineers and the obstetrician, and so definitely, yeah, took advantage of that hospital.
Yeah, I bet. But otherwise, it's a long way to go if you're hugging contractions.
In the winter, yeah. And there's no I-70.
Right,
Yeah.
right.
Do you know why he picked coming down to Boulder and setting up the observatory?
So you mean why he decided to make the headquarters?
I mean, I understand wanting to come down from Climax, but why did you go to Boulder?
He,
The university was, right?
yeah, so what was going on, one of the things that happened is for initially the observatory was a Harvard observatory, and it was just Harvard. It was and then by the end of World War II, especially once the kind of Navy funding, the Army funding got pulled, Harvard didn't really want to be like running the whole shit. Harvard had other observatories and noticed how dusty it was. And so Harvard went into like a partnership with CU Boulder. And they were for a while, I mean, at least for like 6 years, they were kind of co-managing it, and it was a collaboration. So once that happened, it made a lot of sense to have Walter come down to Boulder, and then to affiliate with CU, and there's a department and a building. So that's how the headquarters kind of ended up at Boulder. Eventually, Harvard just pulled out entirely for a lot of different social, political, all sorts of different reasons. And so then it became kind of based, fully in Boulder. And then eventually when he was asked to be the director of NCAR, at that point, he was like, I won't leave Boulder. I won't leave Boulder. I won't leave the High Altitude Observatory. If you want me to run NCAR, it has to be in Boulder. And, HAO has to be like at the center of it.
I wonder if the upper air, whatever it was called, the early part of LAS, which is what I work with now, but I mean, which goes back to the same post-World War II era, and they used V2 rockets to send payloads up to observe the Earth's upper atmosphere. And you would think those observations of the Earth's upper atmosphere that Charles Bath, the first director of LAS. Now, when I arrived and joined the faculty, I was so pleased to meet Paul Robertson. He was very friendly and welcoming. It was a great honor. He was not around for much longer, but I don't remember whether he and Charles Bath got on or whether they didn't. And there's been a lot of, it's up in the air, and these directors get on and don't get on, and sometimes they fall out. But I wonder if there was a factor that this was an opportunity to compare the solar observations that they were making with what was happening in the upper atmosphere.
Oh, and so LASP, or its precursor, was already here at that time?
NASP itself was.
Yeah.
Yeah.
Yes, the
NASP
same
is
time.
76 years old, or 75.
75. Yeah.
Oh, that's interesting.
Last.
Yeah, it's 40, and it started in the physics building,
Oh, yeah.
which is where the APA, it was originally called astrogeophysics.
Yeah.
And he was involved in that. but
Oh, I bet there's a story there.
Both Bath and Walter Roberts.
Hmm.
Some of those first V2s were to look at the Lyman Alpha, we're doing imaging of Lyman Alpha, right? And they were doing solar imaging.
Yeah,
in
yeah.
UV.
In the UV. So I think they're
I'm
related.
sure there was.
Yeah.
Roberts was the founding chair of ABS when it was Geo and
Oh,
Astrophysics.
right. Yeah.
So my question, is, Robert, you sort of described him as getting stuck out here, right? He thought he was on a 2-year,
Well, I mean, no, I mean that in a like, no, yeah.
I suspect it seems like more he found very fertile ground.
Yeah.
And he could expand into Boulder, this open, and set up a department.
No, he didn't. Yeah. I mean, it was very fortuitous in a way, right? Like had he,
Yes, I'm sure he saw a lot of opportunity, and he and Menzel coordinated to move into this university where there wasn't a department, and we can sort of set up a new department in astrophysics and really expand
Yeah.
their base there, because either they were very fortuitous year after year, or they were very much trying to grow into this, in through this university. So, and, the government funding and so on. I mean, it was, seems very intentional.
Other questions? Kevin?
Sorry. My other realization is that we talk about Climax and the coronagraph. Most of the things we see are just prominences, right? They're not the corona per se. They're you did show one, which was the green line. They were measuring,
yeah.
they were measuring and getting some images of the corona, but the most dramatic things, which would have been equally useful to predict the arrival of, strong active regions, were these prominences.
Prominences, yeah.
So I was just, we think coronagraph, but then all the dramatic images are.
But isn't the coronagraph being used to make,
I mean, the coronagraph
Image the
is used to help make those high.
and the prominences are just, I mean, they're rising above the corona.
They're right above the surface.
Yeah. And so they're predictive, or at least at the time they were understood to be kind of predictive in some sense.
Yeah, no, they were. I'm sure they were equally useful, but
And I think they were very impactful on Roberts.
Yeah.
You know what I mean? And impactful. And it's what he then showed all around to kind of get, funding and support.
they were getting my interest in the curve.
Yeah.
What is that image from, the one that's on the screen?
This is an 1881 eclipse.
Okay.
From Japan. It's a glass plate from the glass plate collection.
Yeah, I'd be curious to know with the dust, just how much corona they really could see with the coronagraph.
Yeah, I have some photo in his dissertation. He has all of these, he has some pages of plates where he has photographs documenting all of the different problems. So this is a picture that had dust, snow, and a seed pod. This is a picture where there was extra dust, but no snow and no seeds. This is a picture where something got fogged. You know what I mean? There were so many problems. And it really did take 2.5 years to make something that was usable. Yeah.
Does anybody know if the ionospheric forecasting from these coronagraphs at the time actually worked? Or to what extent they worked?
Yeah, I was wondering the same thing.
Yeah. Because that's a different
That's very-
problem now, isn't it?
Yeah, it is. Yes.
Well, I mean, you've painted a picture of this, he's contributing information to this stockpile of information that's coming from H alpha and sunspots and ionospheric and all sorts of things from around the country, probably. And they're in Washington, they're pulling it all together to make some sort of prediction. So there's two questions, right? There's the question of how effective was that? And one hopes it was fairly effective, but then how much of an impact what was being done by Walt Roberts in Colorado had on that? And that's kind of a different question.
Mhm.
I think the military was using that to plan
Yeah.
activities when they would or wouldn't have radio blackouts. But how much of this was actually trickling into it?
And there's a question about, how then did whatever stories were told, right? Because the news, regardless of what the truth is, I mean, in a way, what the science actually was, it was reported in a certain way, right? And so the story became in syndicated national news in the newspaper that this observatory had done these things. And so then that obviously creates a, that kind of creates a culture and creates an understanding, which then helps kind of establish departments, establish fields. So there, I mean, because I totally hear what, as somebody who's not a scientist in this area, I've asked a lot of people this, and you can read military histories, right? Like that the military produced, and the military will say, yes, this was very important information, right? But that's just the military. I mean, they're just getting that because they read that in some report that they received. So what the information, how much information, the information actually was predictive and like actually helped, that would be a question that would take like a bunch of, somebody here and me and somebody else like really digging into to like try to understand.
War historians, even. I mean, my guess is that if this was solar maximum, something like maybe warning of 10 events or something like that, there may be a blackout in the next 24 hours or next 48 hours. Watch out. Might have affected whether or not they did a particular or delayed a particular.
The war, I mean,
I found a little article, I'll share it in a minute, basically what they were doing, it wasn't ionospheric, it was ionospheric measurements, but they were actually correlating reports of radio propagation. People, actual usage, correlating it, correlating it with the observations. And so never mind what the physics is in between.
But it seems that the National Bureau of Standards was involved somehow, which is interesting. I guess they're involved.
That's what
Is that NIST? Okay, I was wondering. Yeah. Okay.
It was like radio propagation.
Okay, that makes sense.
National Bureau of
They had
Standards.
radio telescopes, and they had, these radio telescopes out on out on the road to lines, right?
Yeah.
They had radio telescopes there that were involved, presumably sending information to.
Well, the National Bureau of Standards at the time was in DC.
Oh,
It didn't come here until 1950.
Ah.
Yeah. And Roberts was really instrumental in bringing it here. Yeah.
Engineered by Menzel, who said it had to be on a site where there was a string of mountains running north-south that rose up at least 2,000 feet.
Also like contingent, and then Harlow.
Any place. That bill, but.
It begins with B.
Exactly. And then Harlow Shapley's son. Harlow Shapley was sort of Menzel's, at that time, Menzel, the chair of Menzel's department. Harlow Shapley insisted on sending his son to be the director, the National Bureau of Standards. So Alan Shapley came here.
About that.
Yeah, I know. Like, yes. And I want this really big house. Right. And I'm going to have a maid, 3 secretaries.
Alan Shapley was a well-known radio astronomer. It wasn't random.
Does anyone from HAO know when the move of HAO off of CU's campus happened? Because I thought that was much later, 1980 something.
I recall,
Yeah.
because I started a few years after that, but they were already on the Mesa telling me, lamenting. They weren't on campus, but they really missed the interactions with CU.
Yeah, I think Ellen Zweibel had started on campus
Yeah.
and then left HAO when HAO moved, or like she had told me about
She was a
it being cold.
avid visitor. She came a lot.
Yeah. So 1980.
It's wonderful. You can ask Bob McQueen and Newman.
And the Mauna Loa Observatory was when, John? When did it first?
1940.
Mauna Loa?
No, in the 1960s,
1965. Got first light in December 65. I'm sorry, I've got Climax on the brain.
How could you not?
I'm not. December 65.
Much less dust and pollen and snow.
Yeah.
Just the occasional volcano.
Yeah.
We don't talk about that.
Yeah, we don't talk about that. Yeah, Ben says still some dust, our observer in Hawaii.
But not like a molybdenum mine with it.
No.
Does any of the observatory still exist at the Climax thing? I know you said the original one is not gone, but
Yeah.
is there?
There are, yes, there are like, actually, there are ruins. And I can, yeah.
It was Chalk Mountains, part of Chalk Mountain.
Yeah, so Chalk Mountain, the Chalk Mountain is where the Climax Observatory was moved to in 1952, between 1953 and 1954, and it was operating until 1974 when it was like decommissioned and all the instrumentation went to different places. And there is still actually like the kind of skeleton of the observatory. It's still there. Yeah, and I'm actually going to I'm going to be in Leadville next weekend, and I'm hoping, I think some of the people from the mine, I think either the president of the mining company or the vice president of the mining operation will probably be there. And so I'm going to sort of think about what I think should happen, it's just there. It's really, it's really amazing. It's this really interesting artifact of the history of astronomy and of the history of the HAO and of kind of like the history of, honestly, like of the West and of this moment in the history of the West. So yeah, there's still a structure there. There's also like a Quonset hut that is locked, and the people at the safety engineer at the mine told me that for a long time, people from Chicago were using this Quonset hut for cosmic ray research, but like nobody's been there in the last, there's like a big question about like what's happening in this Quonset hut. They can't get in. I don't know. The whole situation is so strange because it was really the setup was very strange to begin with, right? Like this kind of long-term lease on a plot in a mining company. And then, what happens over the years to that, over the life cycle of the Chalk Mountain iteration of the observatory, there were all of these changes happening to the landscape, like right around it. Like, initially the Chalk Mountain Observatory was right next to these other little mining camps, town of Kokomo and Robinson. And then in the late 1960s, Climax bought those mining camps and turned them into tailings ponds. So suddenly the observatory was surrounded, it was like waterfront property. There is some water on the, and so suddenly the people that are working there are like going on these hikes around the tailing ponds. It's just a very interesting shifting landscape in so many different ways.
David Ilmore was online earlier. He started at HAO right around sometime in the 70s. So I don't know if he's still on.
I think it was and I interviewed Bao.
Oh yeah.
Bao.
He said he worked there as
Good. Yeah. He's the one who told me about hiking. Yeah, he's the one who told me about like hiking around the water. And I was like, but those were really toxic tailing ponds. And he was like, well, I was young and crazy. He told me also that when he was working there, at the time there were these Basque shepherds, and every summer the Basque shepherds would come with sheep, and they would kind of herd sheep all summer and on Sheep Mountain above Chalk Mountain. That sounded like a really interesting, with that on the one hand, and then on the other hand, these like rapidly expanding tailings ponds. I'm just like really intense landscape.
Any other questions? Nobody said anything from online. Anyone wants to say from online?
Anyone who has
this is David L.
Hi, David.
I worked the summer of '68 at Climax. And at that time, the town of Robinson had just been abandoned, and it was just a series of trailers with one permanent structure, which was a schoolhouse. And in the summer of '68, the schoolhouse still had that around the top of the classroom, a map of the U.S., 48 states. And it was if they saw like everybody left one day.
Wow. I didn't totally, that was very, like, I didn't quite capture.
You were
dropping out. But
Could you,
that was fascinating.
Yeah, could you write in the chat? Because your voice was chopped up.
Could you email one of us?
Yeah.
Email me. You have my.
Yeah, I have.
Yeah, you have my email. Yeah.
You should.
I can send.
Absolutely.
Then we're talking.
Yeah, David came to my talk at NCAR. Yeah.
Observing for digitizing green line, the current we're still room of the big. They do that digitizations in our own site, because they weren't interested in getting.
we're not getting you very well, but we'll communicate soon.
Okay. So,
Thank you so much.
Okay, any other question from anyone?
Yeah, if you have any questions or thoughts or memories or ideas, or corrections, or suggestions, email me. I'm at hana.shell@colorado.edu. Thank you.
Okay, let's thank our speaker again.